So in this video I will show you the sine rules and the cos rule. So the sine and cosine ratio are not only useful for right angle triangle. So we look at the diagram here. Okay, we have the tua ka so, that one must use 90 degree, but if it is not right angle triangle 90 degree, then we can use sine rule and the cos rule. Okay, so this one sine A, so sine A is here, opposite the A is A, so capital A B C is for angle, and the small letter of the ABC is the length. Okay, so this one ABC. So the relationship between the angle and the length here according to the sine rule is sine A over A will be the sine B over B will be the sine C over C. Okay, so this is the sine rule. Okay, so we can express in one go. Okay, that is the sine A equal to sine A over A equal to sine B over B equal to sine C over C. This is the sine rule. Okay, the formula can also turn upside down when we want to calculate the length. A over sine A equal to B over sine B equal to C over sine C. So notice that in each case both the upper and lower case form of each letter is used. Okay, so this means that each fraction that you use require an angle and the length of its opposite side. So these two is look like the same. Okay, so when do we use the sine A over A? When we want to find the angle, then we use the sine A here. Okay, if we want to find the length, then we use this one. So the one that you find, that you want to find, you put up. Okay, we look at the work example 16. In the triangle ABC, A is 80 degree, B is 30 degree, and the length of BC is 15. So we need to calculate the angle of C and then calculate the length of the AB and AC. Okay, so the angle of C is 180 minus 80 and then minus 30. So this is angle of C is 70 degree. So this is angle of C. And then this one opposite. Okay, so we have the AC over sine 30 equal to the 15 over sine 80, and this one divided by this, so we have the AB over sine 70 equal to 15 over sine 80. We use the pair of length and the angle that given. Okay, 15 over sine 80, then AC over sine 30, and then the AB over sine 70. So from here we can find the length of AC and the AB. So multiply here. So the AC will be the 15 over sine 80 and multiply with the sine 30. Then the length of AC is this. You make sure in your calculator it is the D here, stand for degree. It is not D, then you have to go to the shift, set up, angle unit, change to number 1 degree. Then we have the AB will be the 15 over sine 80 multiplied with the sine 70. So this is the answer. So this is 7.62 cm correct to 3 significant figure, and 14.3 cm correct to 3 significant figure. The ambiguous case of the sine rule. The spatial property of the sine function can lead to more than one possible answer. The following example demonstrate how this may happen. In work example 17, in the triangle DF is 10 cm, EF is 7 cm, the angle D is 34 degree. Calculate the nearest degree, the possible size of angle E. Okay, so this one we have one possible only. Okay, so we have this. Okay, so we have the sine E over 10 equal to the sine 34 over 7. Okay, so the sine E is the sine 34 over 7 multiplied by 10. Then this will be the answer, and then the angle of E will be the arc sine. Then it is 53.02 degree. Okay, actually for this angle E we have two possible, because in this case the angle given opposite to the length of the angle given, the length is smaller than the other length here. So for this one we have ambiguous case. We have the other case, which is the E can be here. So this one also 7. So if we, by using the info here, DF is 10 cm, and then the EF is 7 cm, and the angle of D is 34 degree. So actually we can draw two triangle here. So this is the DEF here. This is 10, this is 7, this is 34 degree. And the other one is the first one that we use here, this one. So we have the DEF here. This is 10, this is 7, this is 34 degree. Okay, so this one is equal to 53 degree. Okay, 53. So this is 53. Then the angle of F will be the 180 minus 34 and then minus 53, which is 93 degree. But for this case, we know that it is isosceles triangle, so this angle will same with this angle. So over here this is 53 degree also. So the angle of E here, so case 2, the angle of E will be the 180 minus 53, so it's 127 degree. And the angle of F, so 180 minus 53, 127. So 180 minus 127 minus 34, okay, will be the angle of F here, which is 19 degree. Okay, so 93 and then 90 degree. So this is two possible case. So this one we call it ambiguous case. So ambiguous case, I will call it S. Okay, because this one is the angle side. So we have the ASS case here, ASS case here. So the side that opposite, okay, that side opposite to angle is shorter, then we will have the ambiguous case. That means we will have two possible here.